Good day. The last time we looked at how to determine the ground state term for a p5 atomic orbital. Let's continue today with how to determine the ground state term for a p6 atomic orbital. The first thing is to write down the angular orbital quantum number, which is 1 for a p orbital. The next thing is to write down the magnetic quantum number, represented by ml, which is +1, 0, and -1. Then the spin quantum number. An electron can spin upwards, +half, or downwards, -half. Then we write down the orbital. The p orbital is a degenerate orbital. And then the magnetic quantum number of each orbital. Then we fill the orbitals with electrons by obeying the rules in filling orbitals with electrons. So we first fill with single electrons the same spin. Then we pair up in opposite spin. Remember, we are filling with 6 electrons. The next thing is to calculate the total orbital angular momentum, represented by ml. The total orbital angular momentum is the sum of the magnetic quantum number of the orbitals that contain electrons. The first orbital contains 2 electrons. It has a magnetic quantum number of +1. So taking into consideration the 2 electrons becomes 2. Here 0. Here we have 2 electrons. The magnetic quantum number is -1. So taking into consideration the 2 electrons, we have -2. So 2 minus 2, we have 0. Then the total spin angular momentum, that is the sum of the spin quantum number of each electron in the orbital. Since this electron spins upwards, represented by +half, this spins downwards, represented by -half. Half minus half is 0. So we ignore this, ignore this, ignore this. Therefore, the total spin angular momentum is 0. The next thing is to calculate the spin multiplicity. So let me use a different color. By using 2s + 1, where the s represents the total spin angular momentum, which is 0. So we have 1. Since we have the total orbital angular momentum to be 0, our term is an s term, and the spin multiplicity is 1. So the ground state term for a p6 atomic orbital is 1s. Thank you.